Assalamu alaikum. Bismillahirrahmanirrahim. Welcome to our second class of Service Provider Routing and Switching Specialist, JNCIS-SP. We're just going to see the course outline and course module. I already shared this course module in last classes. There is basically three sections here. One section is routing, second section is switching, and third section is MPLS. So we're going to start now routing section. In routing section, there is multiple module, total 15 module. Okay, so module one, this is only introduction, course introduction. Okay, I already covered in last class. So today I will start module 2, protocol independent routing. Protocol independent routing. So what is protocol independent routing? Anyone have any concept? Protocol independent routing. Basically, static routing is called the protocol independent routing. Okay. Others routing protocol like OSPF, ISIS, PGP, that is defined protocol. Okay, that's why Juniper just static routing. Juniper called here protocol independent routing. They provide some different concept or various concept in static routing. I will share today's lesson. Okay, so protocol independent routing. So basically, we'll discuss about static routing. If you make static routing in Juniper, how to make this one, that will be our today's focusing. Okay, so there is a slide I will share with you, but I will focus in lab basically. So see here, protocol independent routing. Basically, this is a static route and how to define the static route. Okay, so static route is manual. Administrator define the destination and next of our path. Totally organized in manually. So going to our lab to show how to make static routing in Juniper. For this lab, I'm taking two BMX router for checking. This is standalone BMX. Okay, version 14.1. Default RAM 2, Ethernet default 6, you can make it 8. Default CPU 1, that is enough. So set this one. Single. I have made mistake maybe. 1, 8, set. This two router. You can say 8. Juniper router 1. You can say this is Juniper router 2. Just connect to PC with Juniper router 1 and 2 for checking the connectivity after define the static route. Okay, so take the VPC, sorry, VPC, Because the desktop is one and this is two. Very simple then. Okay. Yeah. So when you connect Juniper router, don't connect EM0 and EM1. Don't connect M0 and EM1. M0 for management and EM1 for internal use. That means it basically used for forwarding engine and routing engine, between forwarding engine and routing engine. So in our routing communication or packet forwarding, you have to choose from EM2 to EM7. So first interface is ZE-0 by 0 by 0. Please configure your IP address information in ZE-0 by 0 by 0 gigabit Ethernet interface, not use EM2 or EM1. Sorry, EM2 to EM7. Use gigabit interface. Okay. So connect Z0 by 0 and router 2, select, you can select any gigabit Ethernet interface. I select here both router and same interface and the save. Connect PC, just one is the single interface. Connect one single interface, that is alternative. So, so consider here an IP address for IPv4 and IPv6. Need three subnet. One subnet is here, another subnet is here, and third subnet will be router P2P. Okay. So take IPv4 and IPv6 subnet for testing the connectivity 209.165. dot you can say private IP 10.1.0.0/30. Save it. 10.1.0/24. Another subnet is here. 2.0/24. Now power on this device. So before power on, you can rename this one ABC1. This is optional. DP setting and start almost. Okay. And take IPv6 address here. I can take here 2024 colon ABC colon double colon /126. You can take here 1/127 for P2P. For IPv4, you can take up to /31. Juniper also supports /31 for P2P. In LAN side, choose any IPv6 address 2024 colon ABC colon 1 double colon slash 48. Is the random number 2024 colon ABC colon 2 double colon slash 48. Okay. font size 12. I think 12 will be enough. Router 2, router 1, router 2, and C. PC1, set PC name PC1, and how to set the IP address, IP, then address 10.1.1. Consider 1.10/24. Subnet is 10.110/24. I set the IP address 10.1.110/24, and gateway will be 10.1.1.1. So this is the gateway. This is the format. How to set the IP address in BPC. The command is IP, then your IP address for PC and prefix length, then the gateway. Okay. So BPC2 IP address is 2.10 and here is 2.1. 2.10, 10.1.2.1. And PC name, set PC name, BPC. So PC1 and PC2 configuration, IP configuration done. Then you go to Juniper router 1. Juniper router 1 already getting the login prompt. Default user ID is root and password is root 123. Default user is root and password is root 123. CLI, press the CLI to getting the operational mode, and operational mode just configure then enter. You will go to the configuration mode. Okay. First, show the default configuration. This is configured already. Just set the host name. Host name is Juniper router 1. And there is a logical router configuration. No need logical router configuration now here. So delete the logical router configuration, R1, R2. This is the management interface, CM0. No need management interface for testing. I delete this one and make commit to set the configuration. Same changes will be in router 2. User ID is root, password is root 123. CLI to move the operational mode, edit, um, you can type edit and then enter, you will go the configuration mode. You just press configure, then enter, you will go the configuration mode and edit, then press, then you will go the configuration mode. Same thing you have to done for Juniper router 2. So just copy router 2, delete logical router 1, and delete logical router 2, and delete the management interface. No need management interface from now. Then commit the configuration. So see here, there is nothing configured, just set host name and default root authentication configured, and a user ID is configured default. Okay, and the telnet session is enabled. Okay, now our task is test the static routing. Okay, so consider here a PC1 send traffic to PC2 need routing. Okay, without routing, PC1 cannot communicate with PC2. We already know it. So first set the IP address information in Juniper router. There is two interfaces, G0 by 0 and G0 by 0 by 1. You can, if you configure something in Juniper router, first command is set. So set interface, your interface is C0 by 0 by 0, Z dash 0 by 0 by 0. See here, Z0 by 0 by 0, this is the gigabit Ethernet interface, and this cable is directly connected with Juniper router 2. So there is single IP address. I have to configure this IP address in this interface. So you have to use unit 0. Here, unit 0 means you configure the IP address directly on that interface. Just compare with Cisco router, you configure one single IP address in a single physical interface. You just go to the interface and set the IP addresses. There is no sub interfaces. Okay, this is the same as like unit 0. Okay, unit 0, then you can set your description like this is connect to Juniper router 2 and set your IP address family. In Cisco, IP address is configured IP address for IPv6, IPv6 address. But in Juniper, IPv4 address will be configured under INET and IPv6 address will be configured in INET 6. So INET means IPv4 address information. Then set the IPv4 address. IPv4 address is 10.1.1, sorry, 10.1.0.0.1. My subnet is 10.1.0.0/30. So 0.1/30 INET address. Keyword will be INET address, then type the address. So this is the IPv4 address. Similarly, IPv6 address. IPv6 address is 2024:ABC colon double colon 1/126. This is the IPv6 address. In Juniper boxes, IPv6 already enabled. No need to press any keyword or command to enable the IPv6. Just set the IPv6 address in interface. IPv6 will work like IPv4. Okay, so this interface configuration done. This is one format to configure the IP addresses, and you can go edit interface GA0 by 0 by 1. We can go like this. Here, edit means CD, change directory. Now I move interface, then interface ID, then unit 0. Now I am in a specific directory, a specific section. This is interface section. So I can set here, set description. Description is PC1, that means BPC1, and set family INET address. Family INET address is their address is 10.1.1.1/24. This is IPv4 address, and the IPv6 address is 2024 colon ABC colon 1 double colon 1/48. PPC1 and PPC2, this node uh, not IPv6 capable, I think. Bad command. IPv6 not supported. IPv6 delete IPv6 is 0. Yes, this box only IPv4 support. Okay, no issue. Check from IPv4, then change the PPC1 and PPC2. 2024 ABC 1 double colon 148. Nothing wrong here. Invalid IP address. 2024. I use here 48. 048, 148, 248. I think it's okay. Oh, I need 6. This is wrong. I need 6. IPv6. This IPv4 address, this is IPv6 address. So our address configuration done. I can set here loopback IP address for checking. So set the loopback IP address. Loopback IP address is 10.10.1/32, and this is colon A double colon 128. This is loopback address for router 1, and another loopback address for router 2. A double colon 2. We can use double colon 0 also, but I consider router 1, loopback is 1, router 2, loopback is 2. So set the loopback interface IP address, interface hello 0, unit 0, description is loopback, and the IP address, family, init address, IPv4 address is 10.10.10.1/32. This is IPv4, and IPv6 address is 2024 colon ABC colon A double colon 1/128. This is very basic configuration. So our IPv4 and IPv6 configuration have done. If you see the configuration run, um, I press here run because I'm in configuration mode, and execute operational mode command. So that's why press or type run at first. Run show interface doors. You can see this is the interface detail information like Cisco show IP address interface. See here the interface Z0/0. This is IPv4 address that I need. And this is the IPv6 address that is INET 6. Also Z0/0/1. Same. Interface is up and set IPv4 and v6 address correctly. Run show interface description. This is the verification command also. This interface is connected with router 2, and this interface is connected with VPC1. Both interface, admin, and protocol up. So run show route. This command will show you the route table. Okay. See the route table. There is two route table. One is inet.0. This table for IPv4. This is the IPv4 route table. IPv4 route table name is inet.0, and inet6.0. This table for IPv6. This table for IPv6 route table. Okay. So in this table, see here all route, here direct or local. That means I configure the IP addresses, and this address is basically connect with the interface. That's why we see here protocol information direct. Direct means see here the network, and local means those IP address is configured on that interface. This is called the local. Okay. So same thing will be configured in router 2. Let's set. Router 2, this description is router 1, and IP address is /30. Here I use 2, IPv6 will be 2, and one interface will be VPC2, and IP address will be 2.1, and IPv6 address will be 4:1 48, and the loopback is 4, and 6. So from the configuration, run show interface starts mesh. You can mesh only the interface. Okay. You can see details. Okay. Show interface starts. Show interface description. Show route. After configure, check this command. Specific interface run show interface starts. You can mention interface ID to see the details. Okay. See here, single interface details. If you want to see the interface physical information details like this, like empty information, then others information like speed, incoming, outgoing packet. Okay, which address is configured here, which one is the broadcast, which one is local, what is the network, everything will be showing here. Okay. So now, so our target is to send traffic from VPC1 to VPC2. So can I send traffic from VPC1 to VPC2? Is it, will it work? Will it work if I send packet from VPC1 to VPC2?
No, it will not
Will it
work.
work?
No, no,
Not
no, it
work
will not work because we
because
need a routing.
there
We need
is
a
no
routing.
routing. There
Exactly.
is no routing. Okay. Destination network and receiving. There is no routing. Okay. So make the routing or configure the routing protocol. First, we choose protocol independent routing. First, we choose protocol independent routing. In Juniper, protocol independent routing means static routing. So now I show you how to configure the static route. Okay. So go to the lab. From router 1, edit routing options. All static route will be defined here in routing options section. All static route. It may be IPv4, it may be IPv6. Okay. So set multiple options. See here static command for static routes. Then information is to number three options. Uh, there is apply group option. This is different, but three option I will discuss three option. These three option basically two option defaults and route. So first I discuss in for to discuss in route section route set static route, then mention the destination. Just consider with Cisco, if you configure a static route in Cisco, so first keyword is IP route, then set the destination block or destination prefix, then set the next hop. Okay. In Juniper, set static route. This is the command keyword, and you have to set the destination here. So now I am in router one. Now I am in router one. So I want to move router to LAN. So router to LAN is not directly connect with router one. That is connect with different router. So I ask router one, if you go to this destination, you have to go first router two. You have to go first router two. So if I want to go to router two, so my path is single, only single path is here. So what will be the option? Number one option, I mention here exit interface, or I mention here the forwarder router IP address or next of IP address. Here P2P subnet is /30. Now I configure here dot one, this subnet dot one last octet, and here I configured the dot two. So I ask router one, if you go to this destination, please first go dot two. That means 10.1.0.2. Then you will connect 10.1 to 0 network. Okay. So make the routing. So my destination is 10.1.2.0/24. So set here 10.1.2.0/24. And what will be the available option? Multiple available option here, but I chose next up, next hop, next hop. Next up means next hop to destination. Next up to destination. Command keyword is next hop. And after next hop, you have to set the next hop IP address. So here next hop IP address is 10.1.0.2. 10.1.0.2. This is the next of IP address. And others, you also get others parameter here, like yeah, UC resolve, UC re-advertise, UC qualified next hop, retain, multiple options here. So I discuss this option after configure the basic portion. Okay, this is very basic. This portion is the destination prefix and prefix length, and this is the next of IP address. Okay, this two option is mandatory to make the static one. So done. So show here, say static route is this, and the next up is this one. So make the commit, Go to router 2, edit, routing options, show, site here. Just copy this one. Sorry, this will be wrong. And for router 2, my destination is 10.110/24. 10.110/24. And next up IP address is .1, 10.1.1.0.1. This is a wrong route configured here. Just remove this one. Delete static route, then destination. So just make the commit. After completing this configuration, if VPC wants send traffic to VPC 2, is it possible? VPC can send
Yes, possible.
traffic to VPC 2 now? Possible, right?
Possible.
Possible. Okay. So send a packet. Yes, it's working. Clear? It's working because we know packet basically when lookup happened, they search the destination. So VPC1 have default route to router 1. So every packet will come in router 1. In router 1, they have a route. That means VPC1 want to go 2.10. So 2.10 will be in 2.0/24 in this network. So in this is a internet interruption.
Yeah, sir. Actually, you got disconnect, Mr. Bilal, and
Yes.
the screen got blank.
And this for internet interruption.
Yeah, it's okay. We can
Sorry
understand.
for
It
that.
happens. Yeah. It's okay. It's okay. It happens. We can understand. Yeah. I was just asking you.
Okay. Okay. So just run show route and press the destination IP address here. It's the router 1. Router 1, see the router 1. Router 1, tell the packet to move this next hop. So if I see in router 2 say this network is connected with me, and the exit interface is Z is 0/0/1. Packet will go Z is 0/0/1. That means this subnet is directly connect with this interface. So communication happened. So see here, number 1, when you set the static route, this is the destination. The routing information source is static. Star means active route. 5 is the static
Preference
route
value.
preference. Juniper use preference 5, but in Cisco, preference is what?
I think 1.
AD
Preference is
value.
1.
It's 1.
AD
AD
value.
value.
1.
I have 1. But Juniper have exception. Juniper use 5 AD value. But Juniper this value called preference. Okay. And this is the next step. Which one I have mentioned in configuration. And this is the exit interface. So similar in Cisco, if you see the Cisco route table, say the destination, see the next hop, exit interface, and which routing protocol is used to raise the destination. Okay. For static route in Cisco, show the S, but in Juniper, their full name is static. Okay, so one thing 5 is the default static route preference. Okay, so if I configure static route, you have to mention two things. One thing is which will be the destination and which will be the path or which will be the next step. Okay, this two parameter is mandatory to mention the static route. Okay, so I can configure the static route now, right?
Yes.
Right? Okay. Just one question. If I send packet from Juniper router 1 loopback interface to Juniper router 2 loopback interface, is it possible to send packet from router 1 loopback to router 2 loopback? Is it possible?
Until and unless if you don't put static routing for the loopback, it will not work for sure.
Yes. Fine. Thank you. This is not possible. Need routing protocol because those loopback address is connected with different router, not a single router. Okay. This is the reason. Okay. So if consider here, this is the first example, very first example, and I will go, oh, sorry, complete the IPv6 also. Complete the IPv6 also. Okay. So for IPv6, VPC1 or VPC not support the IPv6. In that case, I can take here Juniper boxes or other devices which will support the IPv6. So, mm, so allow me some time. I just pause this record now. Changing the device. Okay, some changes in VPC1 and VPC2. For previous, basically in EVNG VPC, not support IPv6. That's why I changed VPC1 and VPC2 with Juniper boxes. VMX basically. Just I change the time. VPC1. Delete the extra configuration. Oh, this is VPC2. Sorry. This is VPC1. Delete logical router. Delete router. So set the IP address in VPC1, set the IP address is set interface GE dash 0 by interface is 1 and it's 0 description address IPv4 10.1.1.10/24 is the IPv4 -6 -6 address 2024 colon ABC colon 1 double colon A slash 38. And set the default routing. Set routing options, static route, and static route gateway will be 0 by 0. This is the default route. And next up will be 1. This for IPv4. Commit. Show route is the IPv6 table. So set routing options RIP for IPv6 static route. Set routing options RIP, then routing information base is INET6.0, then static route. This is the difference between IPv4 static route configuration and IPv6 route is static route configuration. And 6.0 is static route, and IPv6 default is :/0. Next up will be
Sorry, can you tell me why we use RIB, RIB?
yes, of course. See here, branch route. This is the route table for IPv4. Default, when you mention the static route default, that will be in INET.0 by default. But you have to set the static route for another route table. Route table is INET6.0. Okay, that's why you have to place the configuration which table you want to configure a static route. That's why Juniper boxes have option.
Okay,
RIP,
if you are
which
configuring,
table? Which table?
okay,
This table.
okay.
This is static route for this table. If I not mention this one, this route by default will be in INET.0.
Okay, got it, got it. Okay,
Okay.
thank you. Yes.
So set here is static route. So checking the connectivity, ping the gateway IP. Yes, it's working. So now complete the IPv6 in VPC2. So set the first set the IP address. Interface is same 1. So this is connected with router 2. Copy the IPv4 here. Change the IP is 2.10. VPC1. Copy this one. And this will be 2 minus 6. This is IPv6. Okay, IPv6 address configured. Then set the default route for IPv6. For IPv6 default route, this will be 2:1. And for IPv4, that will be 2.1. So my PC1 and PC2 configured done. Checking the connectivity. So display there from PC2. Check the V4 gateway, run ping 2.1. Yes, it's working. And send ping to IPv6 gateway. Yes, it's working. Okay. So if I send packet from PC1 to PC2, with respect to IPv4, that will work, right? We already configured the static route in router 1 and router 2 for IPv4, not for IPv6, right? So edit routing options show there is no IPv6 route here. So set the IPv6 route, set routing options, show set RIP, then RIP name. Name will be 106.0. Copy this one and static route. Our destination is I'm in router 1. So my destination will be 2024 colon ABC colon 2 double colon /48. This is our destination for router 1. As like IPv4 static route, set static route, just mention the table name here. This is the destination, and next will be the next hop. Next hop will be top. So this is that. Next hop will be a C0 by 0 by interface IP address. This IP address will be next hop for router 1. So this is the IPv6 static route, and from it here. So this is that for you can set from globally set routing options. RIP name is INET6 INET6.0, and the destination is LAN prefix. LAN prefix is this one 48. And sorry, RIP static route. Next up will be Z0 by 0 by interface IP address, that is double colon 1. So set the IP address here. This is the reverse static route from router 2. If I send packet from PC1, just send packet, see here, so display set. If I send packet to 2.10, this is IPv4 on PC1, run ping. Yes, it's working. And run trace route, the destination IP. This is the trace path. First one is PC gateway, then router 1 and router 2, IP addresses, then router 10 is VPC2. Run ping for IPv6, copy the IPv6 address A. Yes, it's working. Trace route. Yes, it also working. This is the gateway. This is from router 1 and router 2. And 2 double colon A is the VPC2 IP address. So communication happened. PC1 can communicate with PC2 in respect IPv4 and IPv6. Okay. Any question or query? Is it clear up to now?
Yes, it's clear. Thank you.
Okay. So now I check. Just consider this is a customer router. Router 1 is the customer router, and router 2 is the ISP router. So customer have 2 links, primary and secondary. So if primary goes down, traffic will be passed through the secondary link. Okay, you have to configure static route so that if primary link down, all traffic goes to secondary link. Okay. So again, I have to stop this. Pause the record. Okay, I have changed in topology. Just connect another interface in between router 1 and router 2. One will be work as a primary link and another will be work as a secondary link. Okay. So I'll just show it. See here IPv4, IPv4 route table and IPv6 route table. There is 3 routing information sources. One is direct, it's local, and last one is static. Okay, this is the static route for IPv4, and this is the static route for IPv6. Similar, just address, sense the addresses, nothing. Okay. Now I can check primary and secondary. In Cisco, what we know, if I make the static route AD value default is 1. If I make another static route, another same destination static route in separate interface from same router, and that set the AD value higher than the default. Okay. So same concept will be work in Juniper. And so first configure the secondary interface IP address first, then check the static route configuration for secondary interface. So set interface CE 0 by 0 by interface will be 2 unit 0. Description. This is router 2. Router 2. This is U and D secondary. And, normally I need address. Address is duplicate. This address is 4, and this is double colon 4. So IPv4 address will be 10.1.5/30 and -6 address 2024 colon ABC double colon 5/126. So address configuration done. Sure, just press it. Interface 2, router 2, there is connect with router 1, IPv4 address 5, here address will be 6, 6, 5, address will be 6. Okay, so address configuration done. Now I set the static route in router 1 and router 2. Just see here, this is the static route for IPv4. If I make this static route for secondary link, that next up will be 6, right? Next up will be 6, right? Secondary link interface is
Yes, the
2.
connected
Yes,
interface,
yes.
correct. Yes.
Yes, okay. For router 2, For secondary, IP will be 5, right?
Yeah.
From
Yes,
router
correct.
to 5. Same thing will be happened for IPv6, but before configuring the IPv6, check first the IPv4. Run show route. See the IPv4 um, 10.1.2.0/24. Run show route. This one you configure, right? Secondary Z0/0/2 you configure. But when you check the route table, now it's working. Same thing. You press here, run show route. This one, check. So this is the destination, and this is active static routing protocol. Preference is 5. Next up is there is 2 next up. Both are inactive. There is 2 next up. Both are inactive. 000 and 002. This is the route table. You know the route table and forwarding table. What is the difference
Yes,
between
and
routing table and forwarding table?
in a routing table, you can see all the routes, and in the forwarding table, you can only see the best route.
Correct. Correct. So if I see the forwarding table here, run show route, forwarding table here. So see the my destination is 2.0/24. This is basically big. 2.0/24. Better I mention the destination. Um, destination. My destination is 2.0/24. See here. In forwarding table, this destination next up will be 0.6. Next up will be
The second one.
0.6.
The
Second
second
one.
one. Yeah.
Second one. So if I make both in routing table, both are inactive, but in forwarding table, I see is greater than sign. Is greater than sign. See here.
The preferred
This is
one.
the symbol to understand which one will be in forwarding table. Okay. This is greater than sign. Tell you this next up will be in forwarding table. Okay. And from router to same. From router to same. So this happened secondary. Now secondary is primary, but primary is going to secondary, right?
Correct.
So I want to make primary as a primary and secondary is a backup or secondary. So I have to work. I have to work with preference, add value. I mention here static route, but not mention the preference when define the static route. So see here. So this is the first one. This is the first one static route. So if I mention here preference is I can set the value here. What will be the preference? I can set also here preference. No issue. Okay. After next hop, I can set the preference, or I can set route, then destination, then set the preference. So if I set the preference like this is default. Sorry. This will be the secondary, okay? So take this one and set the preference. Preference is 10. See the difference. Route. See here. Now this is the primary. Clear? This greater than sign is here. If you see the forwarding table, this is in now forwarding table. That means this is a primary. Scattering sign, this is a primary, and this next hop or this interface will be treated as a secondary. But both static route, for both static route, preference will go to 10. But I want primary preference will be default, that is 5, and secondary preference will be the 10. This is for our desire, but this configuration sends the route preference 5 to 10 for both next hop. Juniper will work like this. If you make this link as a secondary, then you have to set not the next hop, set the qualified next hop. You have to set the qualified next hop. This is the difference. Okay, this is the difference. So instead of next hop, I mentioned here qualified next hop. So go to routing options section, routing options. See here, static. So static route. Next hop, I make here static route, this one. This is the destination, and check here next hop and qualified next hop. This is the next hop to destination, and another one is qualified next hop. Next hop with qualifiers. Here we mention the preference. Okay, so qualified next hop and mention the qualified next hop. Which one will be the qualified next hop? 6, secondary. And you mention the preference here, like you mention your preference 10 or 9, anyone greater than 5. Understand? So I mentioned here 9. So some extra configuration is here. I remove this one. This one is extra. See here, this is the next hop, this is the primary link. This next hop preference will be 5, that was default. So this preference we should delete. Now it works. So only preference is delete. Okay. Now it works. Say this static. Your destination is this one. So for this destination, your next hop is this one. So this next hop preference will be default. And for this next hop, preference will be 9. So this will be the primary automatically, and this will be automatically treated as a secondary. If you make primary, secondary, and tertiary connectivity using static route, you have to mention the qualified next hop. Okay. So run show route. This route is, see here, make the commit. See here, which one is active? This one is active. This one is active because this preference is 5 and this preference is 9. Lowest preference will be winner. Here, 5 is lowest. This is primary and 9 is higher. So this is secondary. Clear? Qualified next up. How to configure primary and secondary?
Yes, clear.
Yes, clear.
Yes.
Okay. So same for IPv6. If you configure the IPv6, same consideration you have to take. Just set RIP and it's 6.0. Static route will be this one, but you mention here qualified next up, not the next up. That will be the qualified next up, and next up will be the 6. And you have to mention the preference. Preference must be greater than 5. You can set 7, you can say 8. So say I take a 9, 7 for IPv4 and IPv6. So check the IPv6 route now. IPv6 route, my destination, this one. So see here, this is the active route and this is the backup route. Okay. Same thing I configured in router 2. Edit routing options. Show set static route qualified next hop. My next hop will be 5 and preference will be 9. Show display set. There is extra configuration here. Remove this one. No need this one. Yes. So set RIB and 6.0 static route. Route is this one. And set the qualified next hop. And qualified next hop will be 5, right? 5. And preference will be 9. Done for IPv6. Commit. Check the IPv6. Transfer route. IPv6 is the active route and this is the backup route. You can see the forwarding table. Transfer route. Forwarding table. Destination. Mention the destination this one. And check here. :1. This is the primary. :1 is the primary because star is the active. Okay. Now I check if I send packet from PC1 to PC2, that will use the primary link. That will use the primary link. If primary link fail, that will be goes to the secondary link. Okay. So check this one. Show this person. So this is my IPv4 address from PC1. Send the ping request. Destination. Yes, it's working. And make the trace. Trace is working. So again, run the ping and down the primary interface from router 1. So set interface. My primary interface is E0/0/0, 0/0/0. Disable means I shut down the Z0/0 interface. Okay. So shutdown done. After shutdown, check the static route. Gone. Primary route has gone. Right? Now active is secondary. Secondary one is active. Okay. Then check the connectivity. Check the connectivity. Working. Working? No, not working.
Oh, okay.
So what is the reason? Why not working? Because
We
router
have to
one
do the
packet
static
is
route
coming
here.
in router one. Packet is coming in router one. Router one tell this packet go to this next hop using this exit interface. See 0 by 2. Now packet is in router 2. See this router 2. See the route table 2.0. This is direct. Packet is in VPC2. If this is the forwarding, just making the reverse, when PC2 is send the response to PC1, that is reverse, when they are just going to 1.0. That means 1.0, there is 1.0, next hop is primary link. 1.0, next hop is primary link. But in my router 1, primary link, I manually shut down this port. But this router not sense. My remote router not sense. Neighbor interface goes down. Not make sense. Because this is a static route. That's why this not make sense. If you make it sense, you have to configure scheduler or event options or RPM probe like Cisco IPS7. You have to make sense. So this is the limitation of static route. You know this one. If I disable Z 0 by 0 from router 2, that will work. Otherwise, it will not. Otherwise, it will not work. Clear?
Yes, clear.
Okay. So if I make set interface CE 0 by 0 disable, see here, 1.0 secondary link, and you will get ping. No issue.
So just a second. So you mean to say we have to disable the interface on both sides, right?
Both sides.
Okay, got you.
You have to disable in both sides. Otherwise, it will
Okay,
not work.
yes.
Because
Not
this is the
work because
Ethernet port. This is the
Ethernet
Ethernet port.
Yes.
Ethernet port does sense remote site information.
Mm-hmm.
If I make this one like SAP, if my fiber is down or SAP unplugged, my remote device will sense what is down.
But in this
Protocol is down.
case, sorry, just interruption. In this case, if the router one interface, because in the live scenario in the environment, we are not aware which interface will get down. Okay, right?
It's
So
maybe
if
fiber down.
okay, you mean to say we have a fiber, right?
Yeah. Either between router
Okay.
Router cable. It may be UTP cable, it may be fiber.
Okay, got you. Then the scenario is good.
Okay.
Okay, fine. Yeah.
So this is the limitation of static route. So in that case, we are using a dynamic route for some limitation. If you make it dynamic or make sense, you have to place here RPM probe. RPM probe basically continuously communicate with the next hop. If next hop is unreachable, they make the route change automatically as like dynamic routing protocol. Okay. So static route have some helping hand to make it sense or make it primary, secondary failover. So, okay. So now we just tell about static route, primary and secondary, how to configure primary path, how to configure the secondary path, how to mention the preference, and new thing is qualified next hop and qualified next hop. When we use qualified next hop?
Bhaiya, I have one question.
Yeah.
In real scenario, if primary link fiber is down, getting down, that means both side port will be shut down, right? So then traffic will
Both
be
side
automated
port,
shift.
yes.
Then traffic will be shift secondary link.
Shift to secondary.
Okay, okay.
Otherwise,
Here
no.
we here we disable, here we shut down one side port, but at the same time other side port.
This will not work.
This one. Okay, okay, I get it. Got it.
This
Yes,
will
sir.
not
You was
work.
asking some. You was asking a question. Please, can you repeat the question?
Oh, yeah. Question is when only single link between customer and ISP need qualified next hop, configure need qualified next hop.
Yes, okay.
Just consider scenario is only this is the customer router and this is the ISP. Only single link is here. Only single link.
Only single link, we don't
What,
need a qualified desktop.
Perfect.
Qualified desktop only we use if we have a backup link. So we are
Backup.
saying that exactly backup link.
Right. Backup link. It will be for secondary, it will be for tertiary. Okay.
Exactly. So if we only mention the qualified command and if we don't put the preference, still it will work or it will not work?
If you don't mention the qualified desktop, you
No.
just
If I don't mention a preference, I am mentioning a qualified next hop, but not mentioning a preference. Then what will happen?
Default both path will get the default static route preference.
Okay. But because
Just
I am putting qualified, so it will work or it will not work?
No. You have to place the preference.
Preference. Okay, you are saying it's mandatory. It's mandatory, right?
Mandatory.
Okay, got
Just
it.
see
Got
here.
it. Got it.
Just
Got
see
it.
here.
Yeah, got it.
Static route. This one. Qualified next hop. This one. Delete the preference. Okay.
Yes.
See here. There is no preference.
Okay.
Next hop. This is the next hop. This is the destination. This is the next hop. This is the destination. From this one.
Got it.
Run, show, route, destination. See here. Both preference 5. Both preference 5. And this is in forwarding table. Because it's greater than.
Got it. So you
But
mean to
make
say
sense.
we are put but you mean to say we are adding a preference because we want our selected route in a forwarding table, right? Got it. Okay.
So I mentioned here the preference to define this will be in routing table, not secondary will be in routing table, not in forwarding table.
Forwarding table.
Manually
Yes, got you.
Okay.
Got it. Yes, I got you.
So today is the 10:30, right?
Yes.
So I think today enough. So I have just finished 2 slides. The static route concept for IPv4 and IPv6 and primary secondary concept. Okay, that's for all today. Next,
Thank you.
I will discuss next slide. That will be coming Sunday maybe. Okay, thank you very much.
For that. Thank you. Yeah, take care. Bye.
Thank you, sir.
Assalamu alaikum.